Today we are going to discuss about shrinkage of concrete and creep of concrete and how shrinkage and creep ultimately affecting the prestressing steel in terms of its stress. So shrinkage of concrete, especially in the prestress member, is happening mainly due to the gradual loss of moisture, which ultimately result in changes in volume. So now there are two types of shrinkage. One is autogenous shrinkage and another is drying shrinkage. Now the autogenous shrinkage strain develops during hardening of concrete, and especially the major part of it develops in the early days after the casting, and is a linear function of concrete strength. So it should be considered specifically when new concrete is cast against hardened concrete. And the drying shrinkage depends on the aggregate type, quantity, relative humidity, water cement ratio, time of exposure. Now the rich mixes exhibit a relatively greater shrinkage than the lean mixes, since the contraction of the cement gel increases with the cement content, as the rich mixes contain more cement than the lean mixes. Now rate and the amount of shrinkage of the structural members under general atmospheric condition will depend very much upon the ratio of surface area to the volume of the member, and as the exchange of moisture between concrete and atmosphere must take place through the surface. So exposure condition is very important because it depend upon the relative humidity of the ambient condition will ultimately going to affect the shrinkage effect, how much a concrete can lose its water through exposed surface from its core. So shrinkage is liable to cause cracking, but it also has the beneficial effect actually. It helps in strengthening the bond between concrete and steel reinforcement. Total shrinkage of concrete is influenced by its ingredients, size of the member and environmental condition. And the total shrinkage also depends upon the total amount of water which is present in the concrete at the time of mixing. And also it can be reduced by using minimum cement content and lower water cement ratios. So the crack caused by this shrinkage can be controlled using steel reinforcement, especially close to the concrete surface. And that is why the course of practice specify minimum quantities of reinforcement for this purpose, how much you can provide. Now the progressive inelastic strengths, especially due to creep in a concrete, are likely to occur under the smallest sustained stresses at ambient temperatures. And shrinkage and creep of concrete are basically similar in terms of in origin, and being the largely result of the migration of water in the capillaries of the cement paste. As the increase in strain under a sustained stress is several times larger than the strain on loading, it is of considerable importance in the prestressed structural members. And even the various factors can influence the creep of concrete, like relative humidity, stress level, strength of the concrete, age of the concrete at loading, also duration of stress, water cement ratio, type of cement aggregate in the concrete. And creep of concrete continues for a very long time and tending towards the limiting value after an infinite time under load, theoretical infinite time under load. And though the rate of creep decreases with time, so it continues for a very long time. Even the main portion of the creep happens within very short time. Let's say if creep under 1 year under load is taken as 1, the average values of creep at later ages is 1.26 after 10 years, where 1.36 after 30 years. So you can see that creep, as it's gone for a long time, the rate getting lower and lower. So how it can affect, actually the strain that develops in the concrete will result in the same strain in the steel, that is in the prestressing steel. When we are studying prestressed concrete, it was assumed that the strain developed in the concrete will create the same strain in the steel. This condition is called the strain compatibility condition. Due to strain because of creep and shrinkage will create the same strain in the steel and that strain multiplied by the elasticity modulus of elasticity of the steel will give you the how much stress it's getting lost in the steel. So as per IS code 1343 2012 edition, you can calculate the creep strain as well as the shrinkage strain. For creep strain, you can go to clause number 6.2.5 of IS code 1343 of 2012 edition. If you go there, you can see that how to calculate the creep coefficient. If you know the creep coefficient, then if you multiplied it with the modular ratio and the stress which will be developed at the concrete at the location of the prestressing steel, if you multiply modular ratio, the creep coefficient and the stress value of the concrete, then you will get the how much you are going to get the loss of stress in steel. Creep coefficient you will get it from IS code 1343 and the clause number is 6.2.5. Same one for shrinkage, you can go to the clause 6.2.4 and from there you can see there part of one is drying shrinkage strain, another part of the total shrinkage strain is the autogenous shrinkage strain. So autogenous shrinkage strain you can get it from directly from the table which is in clause number 6.2.4.2, that is based on the concrete strength. How much autogenous strain will be after some time, that you can get it from clause number 6.2.4.4, and there time at which point you want to know the strain, that you can calculate from the expression given there. So you know the autogenous shrinkage strain at particular time. At the same time also you can calculate the drying shrinkage from clause number 6.2.4.5. There are also three coefficients are there, so that part you can calculate from given equation as well as two tables which are based on the concrete strength, relative humidity value, and the one parameter value that is known as notional size of the cross section, which is nothing but 2 into cross sectional area divided by the how much of the cross section is exposed to drying or exposed to the ambient condition. So that portion, that is known as notional size of the cross section. So if you know notional size of the cross section, age of the concrete at the beginning of drying stage, which is nothing but at the end of the curing, you know the relative humidity value, you know the concrete strain value, that is the characteristic strain value, then from that you can get the drying shrinkage value as well as the autogenous shrinkage value, and then you will get the total shrinkage strength that will be multiplied with the modulus of elasticity of steel, and you will get the how much it can create the loss in the prestressing steel. So you can see, so from shrinkage, so we can now calculate how much loss is going to happen in the steel due to shrinkage and creep. Much of it you can refer to any prestressed concrete book, and especially read the code, the clause number 6.2.4 and 6.2.5 for better understanding of the procedure as well as the what does it mean exactly and how everything is affecting each others. So thank you for listening. Hope you get an idea. So it was just a brief discussion of creep and shrinkage of concrete and how it can affect the stress value in the steel in prestressed concrete. Thank you.